So let's start with theory of integration. So as you can see, integration is nothing but opposite of derivative, antiderivative. So if you know the derivatives list, you can find the integration list as well. So see, derivative is instantaneous rate of change, which is very small thing you can say. But when I talk about integration, it's going to be area under the curve. So it's going to be a huge thing, like area under the curve. So maybe we can see that later. For example, if I have x cube, the derivative of x cube is 3x square. But if I talk about the integral of x cube, it's going to be greater than that. So it's going to be what? It's going to be like x to the power of 4 upon 4, like plus 1 upon plus 1. If it is x to the power of 3 by 2, so integral of this thing is going to be x to the power of 3 by 2 plus 1, which is 5 by 2 upon 5 by 2. Whatever is in the power, it's going to be in the denominator. Obviously, you can solve it further. We know the derivative of sin x is cos x. That's why integral of cos x would be sin x. Similarly, in derivative of cos x is minus sin x, so integral of sin x would be minus cos x. Now this thoda sa, it's you just pay attention in this thing. So since it is sin x, it's going to be minus cos x. You know the derivative of tan x is sec square x, so integral of sec square x is nothing but tan x. Now if I talk about 1 by x, you can use the same formula, that is integral of 1 by x. Maybe you can write this thing as x to the power of minus 1. You'll do the same thing, x to the power of minus 1 plus 1 upon minus 1 plus 1. But the thing is, here you will get x to the power of 0. That's not a problem, but here you will get 0. So it's going to be not defined. So that's why integral of 1 by x is going to be ln x, because derivative of ln x is again 1 by x. Now the thing is, what kind of questions they will ask you? So they will give you find the equation of function from dy by dx or d2y by dx square. So if they give you dy by dx square is equals to 6x plus 6, then you are going to integrate both sides. So d2y by dx square will become dy by dx, and then 6x square. So after integrating, again the laws are simple, that if it is integral of f of x plus minus k g of x, so I can separate the integral from plus minus. It's going to be integral of f of x plus minus k constant outside, just like derivative integral of g of x. But remember, there is no quotient rule, no product rule, no chain rule in this integration at all. We don't have any such things. Okay. So anyway, so we'll get what we took out this constant outside. Integral of x is nothing but x square by 2 plus 6x plus c. Because see, integral of 1 is going to be what? This can also be written as integral of x to the power of 0. Again, we are going to do x to the power of 0 plus 1 upon 1, which is x at the end. Plus c is nothing but the arbitrary constant. So c could be 1000, 10,000, anything. Maybe we need to find the value of c. They will give you that maybe they will give you a couple of points that it is passing through these points, so you can find out that thing. Or maybe dy by dx at particular point is this much, so they will give you these things as well. So it depends on that. You'll have to substitute the values and get the answer. The main application is area under the curve. So this is basically definite integral. Now definite integral will be what? You just integrate normally, and then you just put these square brackets, and these are the limits. Meaning, if I have this curve and this is, let's say, point A and this is point B, if I normally integrate it, I get a arbitrary constant, yeah, integral of f of x and something. But if I put a limit, then there won't be an arbitrary constant. You will get a number as the answer, which will give me the area under this curve. So it's just an operator, basically, integral. So if I integrate g of x, for example, as you can see, f of x, and after integrating we got g of x, let's say. So it's going to be g of b minus g of a, and you will get the answer accordingly. I have taken a very basic example. You can just check it out. You just put 2 and then you put 1, you subtract, you'll get the value. So this is just giving me area under the curve between 1 and 2. Okay, so obviously you might get some different curves as well. But when it comes to something like this, so this the rule I have already mentioned. Now, if it is 0 to 2, 2 to 5 f of x, like integral of 0 to 2, 2 to 5, so we can write this thing as directly 0 to 5, because we are finding integral from 0 to 2. This is only valid for definite integral. So if I talk about a to b, so we can go from a to some midway and then b to some c point. At the end of the day, it's going to be a to c. So that way also you can understand. The main thing is, for area between two curves, what you need to do, you just need to equate y of both f of x and g of x, or you just substitute anything, any which ways. You will get couple of points, or maybe you will get just 1 point, or whatever it is. You just have to find the point of intersection. You just need to figure it out, that from x which values. See, y is the function that is f of x. X is the input values which we need to figure it out. So here, whatever the x coordinate is, so x coordinate of a to x coordinate of b, area under that curve would be my integral. So as you can see, it's going to be f of x integral a to b. Okay. But in case, so this is actually valid for this much, but in case if there are two curves, let's say g of x, and area under that curve will give me this value, area under the f of x will give me this value. So actual area if I want is the middle one. So what I'm going to do, I'm just going to do a to b f of x minus a to b g of x. So that will give me area under the curve f of x minus area under the curve g of x. So at the end of the day, from a to b, now one sec. So now area under curve f of x minus area under the curve g of x, whatever we are going to get, we can combine this a and b integral together, and we can just write this f of x minus g of x just for the simplification purposes. And that's how you will get area under the curve. The main application of integral is basically area under the curve for you guys. There's one more thing which we have in integral. So sometimes you will get it something like this. Let's say, one sec. Integral of sine of 2x plus 3. Maybe you might get something like this. Okay, sine of 2x plus 3. Now here you can find integral directly. So what you need to know, that this is a constant function. Now see, understand, if it is sine of x square, okay, it's a different function under function. So you know, it's a composite type of function. Even this is a composite function, like you are going to do 2x plus 3 and then you're going to find sine. You know, there is this linear function, like 2x plus 3 is a linear function, like I would say like that. Here it's a function under function. It's a 1 x square is going to be parabolic or whatever, that quadratic function, and then sine. So this is a difficult function, so we'll just skip this. Whenever it comes to linear functions, that is sine of 2x plus 3, what you need to do, you just need to consider this 2x plus 3, and you just need to consider the coefficient of x. What is the coefficient of x here? The coefficient of x is nothing but 2. Now that would have been so great if this would have been just x. Now to do this thing, what all you need to do is, whatever the coefficient of x is, that is 2 here, you'll just put it in the denominator. The moment you do that, you can just consider this thing as x, whatever is inside. So now what is integral of sine x? It's nothing but minus cos x. So it's going to be what? It's going to be minus cos of 2x plus 3 as it is. I'll just take one more example. If I talk about integral of, let's say, 3 minus 2x or minus 5x. Again, if this would have been x, it would have been so good. So what we are going to do, we are just going to consider this x by doing what? By just whatever the coefficient of x is, just put it in the denominator. So minus 1 by 5 or 1 by minus 5. And you can consider this thing as x, and integral of this thing is going to be e to the power of x, which is e to the power of 3 minus 5x. Done. Plus c, of course, whenever it is necessary. So for these functions, you use this thing. And there is one final function which, if they ask you, they may. So for example, if it is sine of x square, which we got, or into 2x dx. Now this is a composite function, and see, obviously function under function, so it's going to be a composite function. Or maybe I'll just take 4x, okay? So sine of x square. Now the thing is, there is no chain rule for integral, but again, we're going to use the same procedure. Now same procedure as in, like, we need to understand whether it's a composite function or not. So see, there are 3-4 functions. 4x is there, obviously it's not a composite function. Sine of x square is there, this is a composite function, and what is inside it is x square. Okay, there is a proof for this thing as well, which we are not going to do, but I'm just going to give you a shortcut because it's a revision thing. So whatever is inside x square, you just see whether its derivatives outside or not. So as you can see, the derivative of x square is nothing but 2x. Just see whether it is there or not. It's not there, it's 4x, but 4 can also be written as 2 into 2x, because see, constant I can just take out outside. So I can write this thing as 2x into dx. Now see, the moment I see derivative of inside a function just next to dx, I'll just consider this thing again as x. The moment I consider that thing, I'll just consider this thing as x, and I'll just leave this 2x dx aside. What I'm gonna get, just 2 constant outside, which was as it is. What is the integral of sine x? It's going to be minus cos, and since I'm considering this thing as x, it's going to be minus cos x squared. Done. I'll take one more example. Let's say if I have integral of e to the power 9, I'll take sec square ln x by x dx, which is a composite function. Obviously you can see that ln x, like, you know, whatever the inside function is, ln x is the inside function. You just check whether the derivative of ln x is there next to dx. Yes, it is there, because it can also be written as into 1 by x dx. Now the moment I can see the derivative of inside function is next, I'll just consider this thing as x. Now the integral of sec square x is nothing but tan x. I'll just write tan of, I'll just consider this thing as x. So tan of ln x plus c. Just ignore this 1 upon x dx. This is a shortcut for finding the integral of composite functions whenever you get it. That's all you have in integration, but definitely area under the curve is very important. So just go through uh, the problem solving of this video. Thank you.